Good morning everyone. So again welcome back to the lecture number 27, right? So in this lecture we will discuss the question number 8 of your NCERT book exercise number 8.1, right? So let us start with the question. The question is ABCD is a rectangle. So first of all we have to draw a rectangle, right? So let's say that ABCD is a rectangle. It is given. Rectangle means the pair of opposite sides must be equal and each angle must be 90 degree. Okay. So you can write it fast that in this rectangle, okay, AB is equal to CD. These are the opposite sides, and AD is equal to BC. AD is equal to BC. Like this, they are also parallel. Okay. So AB parallel to CD and AD parallel to BC, as well as all the angles must be 90 degrees. So A is equal to B is equal to C is equal to D is equal to 90 degrees. So A is equal to B is equal to C is equal to D, which is equal to 90 degrees. So it is given that ABCD is a rectangle, right? In which diagonal AC bisects A as well as C. If we draw a diagonal AC, then already it is given that this diagonal bisects the angle A. It means this half is equal to this. Clear? Similarly, this diagonal bisects the angle C. It means this half must be equal to this half. Okay. So let's say we name it as angle 1. Okay. For our convenience, we take it as angle 1. This is angle 2. Right, this is angle 3 and this is angle 4. So according to the question it is given that angle 1 is equal to angle 2 because AC is the angle bisector of angle A. So we can write and angle 1 is equal to angle 2. Okay, and angle 3 is equal to angle 4. Why? Because already given that the AC diagonal bisects angle A into 2 equal half and bisects angle C into 2 equal halves. Clear? Next, what we have to prove? We have to prove two statements. Okay. So let us first understand the first statement. The first statement is we have to prove that ABCD is a square. What? We have to prove that ABCD is a square. So let me tell you what is a square. A square is a quadrilateral in which all the four sides are equal as well as each angle must be 90 degrees. Clear? But already we know it is given that ABCD is a rectangle. It means we already know that each angle is 90 degrees. So we need another property to be proved. What is the next property? If we can prove that all the sides of this quadrilateral are equal, then definitely it will be a square. So what we will prove now? We will prove that each side, all the sides of this quadrilateral are equal. Then we can say yes, it is a square. So let's prove it. How we can prove it? Let's understand clearly. Okay. See, already we know ABCD is a rectangle. It means this side and this side are parallel sides. AD is parallel to BC and AC is a transversal line. Then this angle and this angle are which type of angle and what is the relationship between them? This angle and this angle are known as alternate interior angle. And we know if there are two lines and transversal line, then the alternate pair of interior angles must be equal. So we can write that this angle is equal to this angle. Okay. So we can write angle 2 is equal to angle 4. Why you can write it? Because they are alternate interior. Is it clear? Okay. So angle 2 is equal to angle 4. Next, since we know that SC is the angle bisector of this angle, it means angle 4 is equal to angle 3. Yes or no? Yes. So we can write that this angle is equal to this angle. Angle 4 is equal to angle 3. Listen, in the place of angle 4 you can write BCA. In the place of angle 3 you can write DCA. In the place of angle 2 you can write DAC. But in order to save time, I write it as angle 1, angle 2, angle 3, angle 4. Okay, so don't be confused. So angle 4 is equal to angle 3. Why? Because AC is the angle bisector of C. Angle bisector of angles. Is it clear completely? Right. Next, let's say this is our this one. This is our equation number 1, and this one is the equation number 2. Let's say. Okay. So already we know that AC is the angle bisector of this angle A. So 1 is equal to 2. We can write it. Okay. So we can write it that angle 1 is equal to angle 2. Same reason. AC is the angle bisector of angle A. Let's say this is our equation number 3. Clear? So now let us analyze all the 3 equations. What we can conclude from all the 3 equations? So from equation 1, 2 and 3. Just look at equation 3. From the equation 3 we got that angle 1 is equal to angle 2. Yes or no? Yes. Now from equation 1 we know angle 2 is equal to angle 4. So we can write angle 2 is equal to angle 4. Is it clear? Similarly, in equation 2 we know angle 4 is equal to angle 3. So we can write angle 4 is equal to angle 3. Done. So what we have concluded? We have concluded that all the 4 angles that are formed are clearly they are equal. Clearly they are equal. Understood? Right. Now it is done. Next thing, can we write or can we extract some conclusion from it? Can we write angle 2 is equal to angle 3 from this conclusion? Yes. Already you know all the 4 angles are equal. It means this is equal to this is equal to this is equal to this. All the 4 angles are equal. It means this is equal to this. We can write it 2 is equal to 3. Right? Now, if 2 is equal to 3, then consider this triangle. Which triangle? This triangle, ADC triangle. In the triangle ADC, this angle is equal to this angle. It means if any 2 angles are equal in a triangle, then their opposite sides must be equal. So the opposite side of angle 2 is DC. So you can write DC is equal to opposite side of angle 3 is AD. Yes or no? Yes, we can write it. This is theorem number 7.5 after 7.6. Theorem 7.6. So we got that DC is equal to AD. Is it clear? Okay. So now let's understand another thing. Since it is a triangle, it is a rectangle. Since ABCD is a rectangle, then we know that DC is equal to AB. We know it. Okay, so I can write DC, or you can write AB is equal to DC. Since it is a rectangle, the pair of opposite sides must be equal. That's why I have written AB is equal to DC. We know it. See, AB is equal to DC. We know it. Simply I have take out it and write it down. Okay. But here in equation number 4, what we have got? We have got DC is equal to AD. We have got DC is equal to what? AD. Right? And we know that AD is equal to BC. This side is equal to this side. So I can write AD is equal to BC. Do you understand this? So what we have concluded here? We have concluded that AB is equal to DC is equal to AD is equal to BC. It means all the 4 sides of this quadrilateral, of this rectangle are equal. We have found out it. Hence what we can write? We can write that ABCD is a square now. Okay? So simply you can write hence ABCD is a square. Okay? So it is now. So clearly and focusedly look at it. You can easily understand. First of all, we have proved that all the 4 angles are equal. Right, all the 4 angles are equal. Now, consider any one of the triangle. This angle is equal to this angle. We can extract it out. 2 is equal to 3. If this angle is equal to this angle, it means This side must be equal to this side, right? Already we know what? That this side is equal to this side. Yes or no? Yes. We know this side is equal to this side. But here we know this side is equal to this side. Since it is a rectangle, this side is equal to this side. It means all the four sides are equal. It is a square. Okay. So we have proved the first statement. Let us understand the second statement. Okay. Okay, students. So in the first statement, we have proved that ABCD is a square. It means all the four sides are of equal length. And now we are going to prove that the diagonal BD, this diagonal BD, bisect the angle B, this angle, and the angle B. So we have to prove that this angle is equal to this angle, and this angle is equal to this angle. So for our convenience, we can take it as angle 1, it is angle 2, it is angle 3, it is angle 4. So what we will prove? We will prove that BD bisect B and D. It means we have to prove one angle is equal to 2 angle, or you can write one angle is equal to 2 angle and 3 angle is equal to 4 angle. 3 angle is equal to 4 angle. We have to prove it. Okay. So let us prove. So first let us consider a triangle ABD. Right, we are considering a triangle. For triangle ABD. Okay, in triangle ABD, AB side is equal to AD side. Why? Because it is a square, and we know in a square all the four sides are equal. So we can write that AB is equal to AD. And if in a triangle any two sides are equal, okay, if it is an isosceles triangle, then their opposite angle must be equal. So the opposite angle of side AB is angle 3, and opposite angle of AD side is angle 1. So we can write angle 3 is equal to angle 1. So what we have found? This angle is equal to this angle. Yes or no? Yes, we have found it. This is equation number 1. Now again, just see. AD and BC are two parallel lines. These are the pair of opposite lines. So they are parallel, opposite sides, they are parallel. And if we consider DB, this one, BDBD, as a transversal line, then this angle, angle 3, and this angle, angle 2, are known as which type of angle? What is the relationship between them? They are alternate interior angles, and we know the alternate interior angles are equal. So we can write that angle 3 is equal to angle 2. Angle 3 is equal to angle 2. Why? Because they are alternate interior. Okay, here we have considered AD and BC as two parallel lines and BD as a transversal line. So angle 3 is equal to angle 2. Okay, let's say this is our equation number 2. Okay, equation number 2. So now what we have found? We have found from the equation 1 that angle 3 is equal to angle 1, and in equation 2 we have found angle 3 is equal to angle 2. Next, since if we consider triangle BCD, so for triangle BCD, BC side is equal to CD side, right? So BC side is equal to CD side. So if any two sides are equal, then their opposite angle must be equal. So BC's opposite angle is angle 4 and CD's opposite angle is angle 2. So 4 is equal to 2. This is equation number. So we have to now analyze all the three equations and write the conclusion. So for equation 1, 2 and 3, what we have concluded? See, in the equation 1 we know angle 1 is equal to angle 3. Angle 1 is equal to angle 3. Clear? And in equation 2 we know angle 3 is equal to angle 2. So angle 3 is equal to angle 2. And in equation 3 we know angle 2 is equal to angle 4. So we can write angle 2 is equal to angle 4. So finally what we have concluded? We have concluded all the four angles, angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4 are equal. So all the four angles are now become same, they are equal. Okay. Now can we write or can we extract from this statement that angle 1 is equal to angle 2. Yes, we can extract because it is given already. Angle 1 is equal to angle 2. All the four angles are equal. So angle 1 is equal to angle 2. Okay. So this half is equal to this half. It means what? It means BD bisect the angle B. Right? It means BD diagonal bisects angle B. Is it clear? Similarly, from this conclusion, we can extract that angle 3 is equal to angle 4. This angle is equal to this angle. Yes, they are equal. We have proved it. And these are two halves. If any two halves are equal, it means what? This angle is equal to this angle. It means BD diagonal bisect the angle T. So it means BD bisects angle T. Clear? So what we have now proved? We have proved the diagonal BD bisects angle B and angle D. Both the angles. Okay. So now we have proved the second statement that the diagonal BD bisects both the angle B and angle D. Hence it is. So understood? Okay students, so let us understand the question number 9. In question number 9 it is given in a parallelogram ABCD. So ABCD is a parallelogram. It means this side must be equal to this side, okay, and this side must be equal to this side, as well as the pair of opposite sides are parallel. Okay, so this is parallel to this and this side must be parallel to this side. We know it. And 2 points P and Q are taken on diagonal BD. So you have to first draw a parallelogram. Then just draw the diagonal BD. Draw the diagonal BD. And on this diagonal we have to take 2 points P and Q. Let's say BD is a diagonal, P is a point here, Q is a point here. Okay, is it understandable? Next, such that we have to take P and Q as 2 points on BD such that DP is equal to BQ. DP means this length, okay, must be equal to BQ, this length. It is given. So DP is equal to BQ, it is given. And from the above data, we have to prove 5 statements here. So let us first understand the first statement, that to prove what? To prove triangle APD. To prove triangle APD is congruent to the triangle CQB. Triangle CQB. Okay. So serially we will chronologically understand each statement. So let us first prove the first statement. So in order to prove these two triangles to be congruent, we have to compare them. So we can write between triangle APD and triangle CQB. Okay, between triangle APD and CQB. Right. So can we write AD is a side of this triangle APD. Similarly, BC is a side of this triangle BQC, or you can say CQB. BC is a side. So can we write AD? I'm very sorry, I have wrongly written it is as P, but it is AD because AD is a side. So can we write AD is equal to BC? Yes, we can write. Why? Because it is a parallelogram and the opposite sides are equal. So we can write AD is equal to BC. Okay. Next, just consider AD and BC as two lines, and we know these two lines are parallel, AD and BC, and BD is a transversal line. It's a transversal line. So what is the relationship between these two angles? It means AD and BC are two parallel lines, and this BD is a transversal line. Then what is the relationship between this angle and this angle? These two angles are alternate angles. Do you know the alternate angles are equal? So this angle means ADP angle is equal to this angle. Yes, CBQ angle. You can write the reason here that they are alternate interior. Alternate interior. It is given. Third condition. For the triangle APD, DP is a side. For the triangle CQB, BQ is a side. So can we write that DP is equal to BQ? Yes, we can write. Why? It is already given. It is already given that DP is equal to BQ. It is already given. This length is equal to this length. Okay. So it is given. So what we have found here? We have found a side, an angle, again a side. This included angle. So by SAS congruency, what we can write? We can write by SAS congruency, the triangle APD, triangle APD is congruent to the triangle CQB, and we have to prove it. Let's understand. Triangle APD is congruent to the triangle CQB, and here we have proof. So this is our proof for the statement number 1. You can write it as statement number 1. Okay. So let's prove the second statement. So in the second statement we have to prove that AP is equal to CQ. This AP is equal to CQ. How we can prove? Okay. See, if we consider APD as a triangle, then AP is a side. Yes or no? Yes. So first write. Since already we have proved that the triangle APD is congruent to the triangle CQB. Okay, since triangle APD is congruent to the triangle CQB, we already know it. Okay, so AP is a side of which triangle? Of triangle APD. Similarly, CQ is a side of CQB triangle. Yes or no? Yes. But we know this triangle and this triangle are congruent. And if any two triangles are congruent, then their corresponding sides must be equal. So you can write AP is equal to CQ. AP is equal to CQ due to CP. And see, this is the second statement that we have to prove. AP is equal to CQ, and we have proved it. So this is the proof for the statement number 2. Okay. So in the next page we will prove the remaining 3 statements. Right. Okay. So now let us understand the third and the fourth statement. Okay. So in the third statement we have to prove that the triangle AQB, this triangle is congruent to the triangle CPD, this triangle. These two triangles are congruent, we have to prove. So let us prove. So first of all we have to compare these two triangles. So between triangle AQB, right, and triangle CPD, let us identify the possible comparison between them, possible similarities between them. So first of all, for the triangle AQB, AB is a side. For the triangle CPD, CD is a side. So we can write that AB is equal to CD. AB is equal to CD. Why? Because it is a parallelogram and the opposite side must be equal. So AB is equal to CD. It is given. Second statement or the second condition. Okay. So if we consider, CD and AB as two parallel lines, CD and AB as two parallel lines, CD, AB as two parallel lines, and BD as a transversal line. Just correlate these two figures. Okay, I have considered CD and AB as two lines or two sides, BD as a transversal line. Then this angle, it means this angle, and this angle, it means this angle. So what is the relationship between these two angles? between this angle and this angle? These two angles are definitely they are alternate interior angles, and we know the alternate interior angles are equal. So you can write that this angle is equal to this angle. So CDP is equal to ABQ. CDP is equal to ABQ. Why? Because they are alternate interior. Is it clear? Moving to the third condition. In the third condition, we have to prove that, see, already in this triangle, ABQ or AQB, BQ is a side, and for the triangle CPD, right, DP is a side. Okay, and it is already given that BQ is equal to DP. That means this side, this length is equal to this length. So BQ is equal to DP, already given in the statement. So these are the three possible conditions. This stands for side, this stands for angle, this stands for side. So by SAS congruency, these two triangles are now become congruent. Triangle AQB is congruent to the triangle CPD. So this small triangle AQB is now congruent to the triangle CPD. Okay, and this is the proof for the third statement that triangle AQB is congruent to the triangle CPD. So this is proof for the third statement. This is 3I. Okay, now it is understandable. Next, moving to the fourth statement, that we have to prove AQ is equal to CP. AQ, this line, is equal to CP, this line. How? Let's understand. So already we know, the triangle AQB is congruent to the triangle CPD. Isn't it? Yes. Now, for triangle AQB is a side. For the triangle CPD, this triangle, CP is a side. And you know, this small triangle and this small triangles are congruent here. We have already proved. If any two triangles are congruent, then the corresponding side must be equal. So AQ is equal to CP by CPCD. And as you can see, this is the proof of the fourth statement that AQ is equal to CP. Here we have proved it, and now it is proved. Statement number 4. Clear? And now let us understand the last statement. Okay, so let us understand the last statement, but before that you have to take a screenshot of it, then I will erase it and prove the fifth statement. Okay, done. So let's erase. So in the fifth statement, what we have to prove? In the fifth statement we have to prove that APCQ is a parallelogram. Okay, so first identify which quadrilateral represent APCQ. See, A, P, C, Q. So we have to prove that APCQ is a parallelogram. This one is a parallelogram, right? How a quadrilateral be a parallelogram? If we can prove the opposite sides of a quadrilateral are equal as well as they are parallel, then we can say yes, it is a parallelogram. So our main focus on proving that the pair of opposite sides are equal as well as they are parallel. So let us prove it. Okay. So we will prove now the fifth statement that APCQ is a parallelogram. So from the statement number statement 2I and IB. From the statement 2I and IB, what we have proved? We have proved that P is equal to CQ. That means this side is equal to this side. Okay, this side is equal to this side. Done. And in the statement number 4, we have proved that AQ is equal to CP. AQ, this side, is equal to CP, this side. Okay, so here we have already done that in this quadrilateral, this side, these are two opposite sides are equal. This side are two opposite sides, they are also equal. So our first target is fulfilled, that the pair of opposite sides are equal. And now our target to prove that the pair of opposite sides are parallel. How we can prove? Let's understand. For this, we have to consider two triangle AQP and CQP. Okay, so between triangle APQ and triangle CQP, we will make them congruent. How? Understand. For the triangle AQ is equal to, for the triangle CP, AQ is equal to CP. Already know. So it is by proved. Second condition, for the triangle APQ, AP side is equal to, for the triangle CQ side, AP is equal to CQ. Already we know, right? It is also by proved. Now, third statement is, for the triangle AQP, PQ is a side. For the triangle CQP, PQ is also a side. So PQ is the common side to both the triangle. Common side. So this stands for side, this stands for side, this stands for side. So by SSS congruency, now the triangle APQ is congruent to the triangle CPQ or CQP. So now you can write the triangle APQ is congruent to the triangle CQP. Okay, do you understand this? So now we have proved that these two triangles are become congruent. If any two triangles are congruent, we know that their corresponding angles, corresponding sides must be equal, right? So since this triangle is congruent to this triangle, then this angle means APQ. Okay, it means, or you can say implies APQ is equal to, okay, this side must be equal to this side, because these two angles, so this angle must be equal to this angle. Why? Because these two angles are the corresponding parts of the triangle APQ and CQP. Yes or no? See, P angle is the corresponding angle of this triangle. Similarly, this Q angle is the corresponding angle of the triangle CQP. So you can write that this angle APQ is equal to CQP. Yes or no? Yes. Why? Because they are due to CP. Right. Now just see. We have taken AP as a side and CQ as a side. Okay, just understand this. AP and CQ. And PQ is a transversal line. And here, this angle means this angle, and this angle means this angle are now proved equal. Yes or no? APQ is equal to CQP. So we have proved that these two angles are equal, and we know these two angles are alternate interior angles. Okay, if there are two lines and a transversal line, if the alternate interior angles are equal, then these two lines are parallel. We already studied about it. So what we can write here? Since this angle is equal to this angle and they are alternate interior, so we can write AP is equal to CQ. Sorry, AP parallel to CQ. Okay. So what we can write? We can write hence implies AP parallel to CQ. Clear? So this side must be parallel to this side. Done. Next. This angle of the triangle APQ. Which angle? AQP angle. And QP angle is the angle for the triangle APQ. Right? Likely this angle CPQ. Now this CPQ angle is an angle for the triangle CPQ. But we have proved that these two triangles are congruent. If any two triangles are congruent, then their corresponding angle must be equal. Right? So if this angle is equal to this angle, then what conclusion we can draw from it? Let's understand. So for this we have to take two sides, AQ and PC. Just understand this. We have taken AQ and CP, and PQ is a transversal line. Yes or no? And here what we have proved? This angle means this angle is equal to this angle and this angle. Now tell me, these two angles are known as alternate angles, and already we have proved that these two alternate angles are equal. And if any two alternate angles are equal, then the two sides, okay, two lines must be parallel. It means this line AQ must be parallel to PC. So what we can write? We can write AQ is parallel to PC, right? So it means AQ is parallel to what? PC. Understood? So initially we have proved that AP parallel to CQ, and these two are opposite sides. So opposite sides are parallel here, and now we have proved AQ is parallel to PC. These two are also opposite sides and they are also parallel. Understood? So here we have proved in this quadrilateral the pair of opposite sides are parallel. Yes or no? Yes. But initially already we know that the pair of opposite sides are equal. So AP is equal to CQ here and AQ is equal to CP here. Understood? So finally what we have concluded? We have concluded in this quadrilateral APCQ the pair of opposite sides are equal as well as parallel. It means it must be a parallelogram. So simply you can write that APCQ is a parallelogram. Right? So hence APCQ is a parallelogram. Okay, so it is now clear.